Alright, well here we are looking at Introductory Probability. As you'd be aware, this is really part of the Year 11 course, but we need it as grounding for the Year 12 work, and so that's why we're doing it now over the orientation period. I'll start off by apologising for the quality of this recording because there's a hum there, particularly when I stop speaking, and it's just some issue I've got with my computer. I'll see if I can fix it, but right at the moment we'll have to put up with it. Alright, so looking at Chapter 7, and we're later going to look at Chapter 13, on Introductory Probability, we'll just go through a few basic principles. There are 4 exercises that we're looking at, 7.1, 2, 3, and well, actually 7.4 we're not considering for the moment. 7.1 is just looking at definitions of what are events, what is probability, and some of the basic aspects of it. 7.2 looks at compound events, such as when we have two things happening, throwing a dice and getting a 1, as well as perhaps throwing a second dice, or a card being turned over, getting a heart, and throwing a dice, or various things where there's a mixture of two events happening and somehow combining. So we look at the probabilities associated with that. And then conditional probability, which is looking at say taking getting a certain card given that some other cards have already been removed. So what's the probability of getting an ace given that 3 aces have already been removed from a pack, or something like that. So there's some rules associated with that. So first of all, at 7.1, looking specifically at that, we've got some definitions. Random experiment speaks here of an unbiased 6-sided die, tossing a coin, even having a baby in there. That's not sort of a fixed event, it just occurs. You could have a boy or a girl, who knows what the result might be, or something more complex. Outcomes is also called the sample space. What results can you get? If you've got a 6-sided die, you can only get a 1, 2, 3, 4, 5 or a 6. Tossing a coin, head or tail, and so on. A baby, having a boy or a girl. So that's the sample space, or the outcomes. An event, it could be an outcome, or it could be a collection of them if it's more complicated. So gives the example of an even number when rolling a die. So the event, notice it's put in set theory, there are the curly brackets there. So even numbers, it would be the set of 2, 4, 6. That would be the event if we were looking at getting a getting an outcome. Here, what's the probability? The probability of success, meaning of achieving whatever outcome you're seeking to achieve, is the number of opportunities to get that outcome over the total number of outcomes possible. So in the throwing of a dice, what's the probability of getting an even number? Well, there are 3 possibilities there. So this would be 3, the number of successful outcomes, either 2, 4 or 6, over how many possible outcomes would there be? Well, you could get any of these numbers here, so there are 6 possible outcomes. So the answer to that question, what's the probability of throwing an even number with a dice? Well, it's 3 chances out of 6, or 1/2. Looking here is the probability of when a equals 0. What does that mean? It means it's impossible. So probability of getting a 7 with a 6-sided die with numbers 1 to 6 on it would be a 0. A 1 means it's absolutely certain. What's the probability of getting a 1, a 2, a 3, a 4, a 5 or a 6 with a 1-sided die that's got those numbers on it? Well, it's certain you're going to get one of them. When we have a series of probabilities of something, the sum of them will be equal to 1. What's the probability of flipping a head or a tail with a coin? Well, it's a half for a head, half for a tail, so they add up to being 1. Expected values, something slightly different. These are what's likely to occur. So for example, if we were going to toss a coin 100 times, we would expect that half of those times, 50 of them, to get tails. So the probability of success, in this case of getting a tail, would be a half, times however many trials there were is the expected number of successes. So if there's 100 flips of a coin, the probability of getting a tail is a half, multiplied by 100. A half by 100 is 50. You'd expect to get your 50 tails, and that's all that means. So this whole part here, it's pretty simple, pretty straightforward in those definitions. Let's look at some problems. Here we have the probability, or it's asking for the sample space here. What is that? What are the possible things that could occur? Something that's less than 10 and, or as well as, a perfect square numbers, so we need to make sure we know those terms. So numbers less than 10 mean all positive integers from 1 through to 9. What are the perfect numbers? These are the perfect squares rather. These are what's 1 squared, 1 is one of them, 2 squared is 4, and 9, which is 3 squared, which are in amongst that group. So the sample space are the numbers that are here and also here are 1, 4 and 9. So there's your sample space there. What's the probability that a number that is randomly chosen from a hat where all the numbers are supposedly put is going to be even? Well, we've got to remember that we put in the hat only those numbers. So only 1, 4 and 9 are in the hat to be pulled out. So there are 3 possible numbers, but only one of them is going to be even, and that's the 4. So what's the chances? The chances is 1 out of 3. Here we've got something, the probability of mixtures of letters in the alphabet. So you've got letters A to Z sitting in a box or something. There's 26 of them. Vowels and consonants, remember that? So you thought you got away from English. Here's your vowels, A, E, I, O, U. So there are 5 of those, and all the others are consonants. So what's the probability of getting a vowel? Well, it's 5 out of the total number of letters, 5 out of 26. What about the probability of getting a consonant? Well, it's all the rest of them. There's 5 vowels and 21 consonants, so it's 21 out of 6. So what's the probability that it's a consonant from the first half of the alphabet in A to M? Well, here, how many out of the 26 letters of the alphabet, how many consonants are there from A through to M? Well, there's 3 vowels into there, so there's 10 consonants because it's 13 letters. So 10 out of 26, notice we cancel down here. We often just leave it as a fraction, and you need to be used to writing it both in fraction form and also as decimals. I don't think I'm going to go through too many of these here. These are really just using these definitions and seeing what we've done. Notice I've done only every third question except for the first 3. Will I do this? You need to remember what these mean. Divisible by 2, divisible by 3. In other words, evenly divide by 7 or by 3. Anything else? I think I might just leave this exercise here. Oh, perhaps look at this one here. A vaccine trial on 2,000 people. So that's the total number of people. It says it's effective if a person has sufficient number of antibodies in their bloodstream 4 weeks later. Yeah, blah blah blah. That just defines what effective means. So the vaccine was effective for 75% of those injected. So in other words, the probability of those who were not protected, since the protected ones is 75% or 3/4, unprotected must be 1/4, but it says how many people. 1/4 of what? Of 2,000, so that's where the 500 comes from. Next question. If there's 20 million people in Australia, there's a bit more than that now, what's the probability that the person randomly chosen is protected? Well, remember 3/4 of the population is protected, and so that means, oh, did I make a mistake there? Just says estimate the probability. The probability is 3/4. What's the number of people? Well, who aren't? Well, again, 1/4 of 20 million would not be protected. It's all too easy, isn't it? We don't really need to go through this. In here, here's a die with these numbers on them here. What's the probability of being less than 1? Well, there are none that are less than 1. So it's 0 out of 6 possibilities, 0 out of 6. What about greater than 6? Well, there's only one number greater than 6, so that's 1 out of 6, and so on.